Hi, I'm Molly, and this is Physics 2212 Lab 4. This lab is circuits and capacitors. We're going to be predicting the behavior of circuits when there are resistors and capacitors, and we're going to do this in series and in parallel. Then we're going to measure the values for current and potential differences. So the model is going to be a circuit with 2 batteries, 2 resistors, and 2 ammeters, and the circuit is modeled with 2 bulbs, a battery, and a capacitor as well. And the assumptions is that the electric field in connecting wires is negligible and that the resistance of wires and the ammeter is negligible. These are the principles we're going to use, the node rule and the loop rule, as well as electrical resistance and capacitance to determine some different values, including the current, the capacitance, etc. This is the experiment setup, with the system being the measuring device and the surroundings being the circuit. And we're going to use a PhET simulation to set up this experiment, to set up the circuits, and add the different pieces. So we set up that first circuit and then are going to measure the potential differences across each of the points listed here. As you can see in that diagram, each point is indicated past a certain point in the circuit. So we're going to measure the predict and then measure the potential difference across each of those points, and those measurements are listed there. And then we're going to add a 100 ohm resistor in parallel to see what changes, because the current now has 2 paths, through the ammeter and then through the resistor. And then we're going to see how the current flows, and we predict that it flows towards the ammeter because it wants to avoid the resistor as it has a higher resistance. And then those values are listed there. So then we're going to do some time-dependent voltage by taking the voltage in 1 second increments from 0 to 20 seconds for a circuit with a 9-volt battery and then the capacitor and light bulb. So we're going to take those values and then they are graphed there, and the line of best fit is listed there with the slope of negative 0.1721. And that can be equated to the resistant capacitance, just calculated there. And the expected RC is 6 seconds. So some errors is that there is likely an assumption of the ideal model because there isn't much error in that model because it is a computer simulation. So human error in that case would not be in the way. However, there would be other errors applied when it is a computer simulation, as there are other confounding things that might happen in real life that aren't accounted for. So if we were doing this with a real-life ammeter, there might actually be a small amount of resistance, because in this case we assumed that the resistance was negligible in the simulation, but if there was a real ammeter, there might be a small amount of resistance. And then if we were doing this lab in real life and use a real battery, the charging time would not be 0 as we assumed it was, as we measured that it was, or not 0, but they would potentially be more because the real life objects have a resistance that would increase the time it takes to charge.